Hey everybody, how's it going? In this video, we'll go over a couple of aspects of being Pythonic. Now, if you've never heard the term Pythonic before, basically, in short, what that means is that you're following conventions and coding styles of the Python language in order to write clean and readable code. So in this video, we'll specifically be looking at two aspects of being Pythonic, and those are duck typing and the concept that it is easier to ask forgiveness than permission. And sometimes you'll see people abbreviate this online as EAFP. Now, these two concepts are very closely related, so that's why I'm putting them in the same video. So first, let's take a look at duck typing. Now, the reason it's called duck typing is because with this concept, you assume that if an object walks like a duck and quacks like a duck, then it's a duck. So what does that mean exactly? That means that we simply don't care what type of object we're working with. We only care if our object can do what we ask it to do. But I think this will be more clear if we take a look at an easy example here to see exactly what this means. So in this easy example, I have two very simple classes here. I have a class duck, and it has two methods, quack and fly. And then I have a class person, and it also has two methods, quack and fly. And both of these methods do different things depending on the class. Now, I also have a function here called quack and fly, and the purpose of this function is that we're going to try to pass in this object thing, and we're going to try to run the quack method and the fly method on it. And you can see down here at the bottom, I'm making an instance of the class duck, and I'm passing that into our function. And then I'm also making an instance of the class person, and I'm passing that into our function also. So first, let's take a look at something that is not duck typed. So this is non-Pythonic. So in a non-duck typed example, we will specifically check if the object that we're working with is an instance of a duck. Now this will ensure that we can use all of the methods and attributes that we want to use. So you can see here right at the top, as soon as we enter the function, it's saying, is this thing an instance of duck? If so, then run these two methods, and if it's not, then print that it has to be a duck. And you can see here that we're running this on a duck and on a person. So if I run this code, you can see that when we pass in the duck to this function, that we get what we expect. It runs those two methods. But whenever we pass the person into this function, it comes back and it didn't meet that conditional of being an instance of a duck, and instead it printed out, this has to be a duck. But if we remember at the beginning of the video, I said that in duck typing, we don't care if this object is actually a duck or not. We only care if it behaves like a duck when asked to do so. So again, you'll see that definition online, that if it walks like a duck and quacks like a duck, then treat it like a duck. So our person class does have the quack method and the fly method, so there's no reason that it shouldn't work in this function also. So let's just go ahead and take out these checks and just try to run it. So I'm going to take out all of this code and just leave where it tries to, and I'm going to leave that print statement in there to get a little space here between these two. So now I'm just passing in an object, and I'm just trying to run these methods, and if it works, then great. So now you can see that if we run this, now it doesn't care what object we're passing in, and it just comes in and it runs both of these methods regardless of what the object is. And that's what duck typing is. We don't care if it's a certain type of object, we only care if it can do what we ask. So now you might be thinking, like, well, isn't this dangerous? So can't we pass in just any object that will potentially throw an error? And that's true. So you might be tempted to say, okay, well, all we care about in this example is not what type of object it is, but whether it can quack and fly. So how about we put some checks in place to make sure that those methods exist? So this is where that second concept comes in, that it's easier to ask forgiveness than permission. So first, let's take a look at the non-Pythonic way to do this, and this is usually called look before you leap. So let me get the snippet out here, and I'm just going to go ahead and copy this code example and paste it into my function here. So in this example, we might be tempted to make a check for each method that we want to call. So first we want to run the quack method. So you might first want to check if that attribute actually exists within our object, and that's what this line does here. Does this thing have the attribute of quack? Then second, we might want to run a check that says, okay, if it does, then is it callable? And if it's callable, then we finally run it. And then we'd have to do the same thing for the fly method also. We'd say, okay, does this thing have an attribute fly? Okay, it does. Is it callable? If it's callable, then run the fly method. So you can see how something like this would be pretty cumbersome after a while. So we're asking for permission at every step of the way. We're saying, can we do this? Can we do this? And then finally, if we pass all the permissions, then we actually do what we want. So that concept that I was talking about, that Pythonic concept that it's easier to ask for forgiveness than permission, frowns upon this. Instead, with that concept, we just want to say, let's try to do something, and if it doesn't work, then we'll handle it. So instead of doing this non-Pythonic way, then let me go over here and grab the easier to ask forgiveness than permission example, and let's look at the difference. So let me uncomment out this code. So right off the bat, you can see that this is a lot more readable. And what we're saying here is we're saying, hey, try to run these methods, and if you get an attribute error, then print out that error. So now if I rerun this code, then you can see that it still works. So it tried to come in and run both of these methods, and it worked. Now, what if we add in a method that doesn't exist? So I'll add in a method here that is bark. Now, if I run this, now you can see that it came in and it tried to run these first two methods, which worked, but then whenever it ran this one that doesn't exist, it threw this attribute error and printed it out through the screen. So it's saying that the duck object has no attribute bark, and it also said down here that the person object has no attribute bark. So if you see people talking about that it's easier to ask forgiveness than permission, then this is what it means. It means try to do something, and if it works, then great, and if not, then just handle that error. Now, this concept actually extends to other use cases outside of the use case that we're using it for here. So I'm just going to go ahead and delete all of this code here, and I'm going to hop over to our code snippets here, and I'm going to grab all of this code here and paste it in, and let me uncomment out this, and let me recomment these two lines here. So this is another small example where we have a dictionary, and I'm going to comment out this section here for now. So we have a dictionary that has a name, an age, and a job. And what we want to do is we want to just print out the name, the age, and the job in this sentence here. And if any of these keys don't exist, then we just want to print out to the screen that we're missing some of these keys. So you might be tempted to do it like this, which is the look before you leap, or the asking permission, which is the non-Pythonic way. We might be tempted to say, do we have this name key in this person? Do we have this age key? Do we have this job key? If all those exist, then print out this sentence that prints out the name, the age, and the job. And if I run that, you can see that it works. Now, if I take this same example and I use a dictionary that is missing this job key and run that, now you can see that it still worked. It said that we're missing some keys. Now, let's compare this example to the concept that it's easier to ask forgiveness than permission. So I'm going to comment out the look before you leap code here, and I'm going to uncomment out this code here. Now what we're saying, we're not making any checks at all. We're just saying, hey, try to print out this sentence that accesses all these different keys. If it doesn't work, throw a key error and say that we're missing a key. So first I'm going to run this with the dictionary that has all of the keys available, and if I run it, you can see that it worked fine. And now, if I run it with the example that is missing the job key, then you can see that it printed out here that we're missing the job key. So you can see the big difference here. We're not making all of these checks saying, can we do this, can we do this, and can we do this? We're just trying to do it, and if it works, then that's great. And if it doesn't work, then we print out the error or handle it in any way that we want to handle it. Now, just another small example here. If I grab another snippet from the list, we can also do this with list. So if I paste this in here, then let me uncomment out this code. And actually, I forgot to actually grab the list here. So let me grab that and paste it here up top. Okay, so what if you had the need to grab a certain index from a list within your code? So you might be tempted to, and this should actually be an equal sign here, you don't want to throw an index error. So what you might be tempted to do is check the length of the list. You might say, if my length of my list is greater than or equal to 6, then I know that I can access this fifth index here. And if it's not greater than that, then I need to print that this index doesn't exist. So you can see that if I run this, then we did print out that fifth index of the list. And if I was to take one of these values out and try to rerun it, then it doesn't pass this conditional, and it's saying that that index doesn't exist. But you can see that we're making this check here, and it's kind of ugly. So that's the asking permission example, which is non-Pythonic. Now, let's just try to do this. So if we just do try to print this index, and then just throw the exception index error, if it's an index error, and print that that index doesn't exist. So now if I run this, you can see that we printed out the index of that list, but if we were to take this 6 out of here and try to run it, then we just throw this index error and print that the index does not exist. So again, this goes back to that concept. We're not asking for permission that we can do something. We're just trying to do it, and if we can't, then we'll handle it the way that we want to handle it. Now, I also want to point out that this isn't an end-all, be-all approach. There have been some situations online where people have pointed out where you might want to make certain checks in certain situations. But why is this easier to ask forgiveness than permission, why is that even considered a good thing to do in most cases? Well, first of all, it's slightly faster in situations where you don't expect a lot of exceptions, because whenever you ask for permission, you have to access your objects multiple times. But here, we just try to access it one time, and if it works, then it works. So we're only accessing that object once. Now, another reason is that some people make the argument that it is more readable. Now, I think this is debatable sometimes, but I agree with that a lot of the time. So I think that this is more readable than the last example we looked at. We're just saying, try to do this and throw an index error if we need to. Also, that example that we saw with our dictionary, we don't have all of those checks in place saying, does this key exist? Does this key exist? We just tried to do it, and then it was fairly obvious that if we get a key error, then throw the key error. Now, one good reason that I saw for writing your code this way was to avoid race conditions in certain situations. So there's actually an example here on the Python docs on the website. So let me grab this code here and paste it in to our file here. And now let me uncomment out this code so that we can see exactly what's going on. Okay, so what we're trying to do here in this example that I grabbed straight from the Python documentation online is we're trying to access this file and then just print the contents out to the screen. Now, you might be tempted to make this check here first to see if we can actually access the file, and if we can, then we'll open it and then print it out to the screen. And if we can't access the file, then we'll hit this conditional here, which will say that the file cannot be accessed. Now, the problem with this, the reason that this is a race condition, is because when we make this check here to see if we can access the file, by the time we get down here in that short amount of time, maybe we can't access the file anymore. So then when we try to open it, then we're going to throw an error. And we're likely not going to catch that error because we thought that we could access the file. So really, the way to do this, which uses that same concept of asking forgiveness and not permission, so let me comment out this code here. So in this example, we're just trying to open the file. And if we can't do it, then we just throw an IO error and say that the file cannot be accessed. And then if we can, then we take the file and print it out to the screen. So you can see that it's just continuing that theme. So instead of asking if we can do something, we're just trying to do it. And if it works, then great. And if not, then we catch that error and handle it as we want. So I think that's going to do it for this video. I hope that it gave you a better understanding of duck typing and the concept that it's easier to ask forgiveness than permission. So these are two very common examples that I see online when someone points out that someone's code isn't Pythonic. So I wanted you to be aware of what those concepts meant exactly. But if you do have any questions, just feel free to ask in the comment section below. Be sure to subscribe for future videos, and thank you all for watching.